If I told you someone could guess you're pregnant, broke, or about to quit your job just from your shopping history and scroll habits, would you believe me? In this video, I'm going to show you how these prediction engines actually work and how tiny bits of poison in the data can quietly break them. Welcome back, nerds. I'm Addie. I've spent 15 years in cybersecurity, and I teach you about cyber threats before they blindside you. Today, we'll go from a real story of a dad who found out through coupons to a $60 attack that can bend a 400 million image AI to what you can do as a beginner to poke these systems legally and safely. By the end, you'll never look at a personalized feed the same way. Ready to see how fragile this machine really is? The algorithm that knew before anyone else. It's 2012, and a father storms into Target, waving a stack of coupons for maternity clothes, baby furniture, and newborn formula. He's absolutely furious. "Why are you sending this to my teenage daughter?" Target apologizes, blames some automated system, and tries to calm him down. End of story, right? Wrong. 2 weeks later, the dad calls back. His demeanor has changed this time, and he says,
"There were things happening in my house I didn't know about, but it looks like your system did."
Target's data team had already done the math. They had built a statistical model, a kind of math engine trained on past shoppers, learned which combinations usually showed up right before someone started buying baby stuff. They had isolated around 24 product combos that screamed pregnancy statistically. Stuff like unscented lotion, vitamin and magnesium supplements, and bigger purses. There were no specific baby items yet. Instead, it was tiny shifts in normal shopping. Each shopper received a pregnancy prediction score. If they had a high enough score, the system timed ads and coupons right into that life transition window when humans are rewiring their shopping habits. A new baby means new routines, which also translates to new brand loyalty that sticks for years. With just diapers, wipes, and detergent, Target can lock in a long-term revenue stream off of a few innocent purchases. Different transition periods are some of the most expensive groups for advertisers targeting because of this desire for that brand loyalty. Here's the creepy but important part. The system inferred forward from indirect signals, and it acted on likelihood. So if algorithms can pull intimate truths out of boring errands and grocery runs, once people realize they're being watched that way, what happens when they start pushing back on the system itself? What data poisoning actually means. Here's the part that will piss off the tech broligarchy. You can mess with the watcher. In machine learning, data poisoning is a real term. It means slipping corrupted examples into training data so the model learns the wrong pattern with full confidence. Zoom that out. At a human level, it's any behavior that trains an algorithm to build the wrong story about you, or about people like you, like binge watching car videos for a week just to see if your feed freaks out. The model can't tell that you're trolling. It logs that as your new real interest. Ad platforms, recommendation feeds, search engines, and For You pages, most of them are continuous learning systems, even when nobody slaps the AI label on them. They run on a few quiet assumptions. First, your clicks reflect real interest. Next, watch time reflects real attention. Third, purchases reflect real intent. Fourth, your past behavior predicts your future behavior too. When those assumptions hold, the system feels psychic. It knows what you want before you even say it. When those assumptions break, the system becomes confidently wrong because models optimize for patterns, frequency, and what looks statistically regular. Tiny distortions sneak in as normal. They can be weird but plausible, but then those distortions get averaged into the way the system understands everyone. So you get this fragile loop. Behavior trains the model shapes what you see, and what you see shapes your behavior, around and around. Now here's the real question. If these systems are built at insane scale, slurping data from hundreds of millions of people, doesn't that scale protect it from manipulation? Or does it actually make poisoning cheaper and easier? Why bigger datasets make poisoning cheaper. Scale turns a $60 prank into an actual vulnerability. A research team looked at a massive 400 million image dataset and ran the numbers. At the time, they estimated they only needed to poison around 0.01% of it. That's tens of thousands of images in a sea of hundreds of millions. Now guess the cost to do that, with hosting and uploads included. I'll give you a second to type your guess in the comments. Shockingly, it's around $60, and that tiny sliver was enough to bend how a model behaved on specific triggers. Think about that. The model still looked normal on almost everything. Accuracy stayed high on benchmarks, but the poisoned pattern, say a certain logo or phrase, and the model slipped into wrong attacker-controlled behavior. Another team at Anthropic pushed this further with language models. They showed that dropping roughly 250 carefully written documents into a training corpus of billions was enough to reliably backdoor the model, regardless of model size. And here's why that works. Models chase statistical regularities. If something looks plausible and shows up often enough in the right context, it gets absorbed into the model's sense of how the world works. The bigger the data set, the easier it is to hide those distortions. Nobody's hand auditing billions of web pages or images. So scale creates this nice, comforting story of robustness while also creating a gigantic shadow map full of places to tuck in poison. In plain English, people assume that there's so much data that a little bad data can't matter, but that assumption is exactly what makes small, targeted poison so easy to hide. I can't help but keep drawing parallels between the tiny fraction of poison data that can reliably corrupt a massive system and Nassim Taleb's concept of the minority rule in Skin in the Game, which is what I've been reading this week. Both scenarios illustrate how a small, non-scalable set of inputs can disproportionately dictate the behavior of an entire ecosystem. So if the math already allows silent distortion at web scale, where do you actually see this fragility show up in your everyday life? Advertising, where algorithms tell on themselves. Digital advertising runs on probabilistic identity. Trackers follow you across sites and apps and pull together a rough sketch. You probably live here, care about this, and earn about that. Behind the scenes, real-time ad exchanges auction access to that sketch in milliseconds. Advertisers buy a 0.86 chance this person is in market for noise-canceling headphones. The whole thing runs on one belief. Signal equals intent, clicks equal interest, and watch time equals desire. But remember the poisoning logic. Once bots, click farms, faked installs, and I clicked by accident behavior flood the system, the feedback loop warps. Campaigns waste their budget on clicks that don't turn into sales and engagement spikes with no revenue on the other side, which results in massively wasted ad budgets. At that point, the deeper problem is uncertainty. Nobody, and especially advertisers, know what a click means anymore. And once nobody trusts what the numbers are saying, the whole data-driven story holding this ecosystem together starts to wobble. Is it a human or a bot, a bored scroll, or maybe even a poisoned signal? Advertising is one of the most fragile algorithmic ecosystems because it depends completely on behavioral honesty at scale. When that honesty dissolves, the confidence that powers the whole system collapses with it. And here's the part that matters for AI and security. If ads are just the training wheels for this kind of interference economy, what happens when the exact same corrupted logic moves from banner ads to the entire web that modern AI models train on? From ads to the web itself, model collapse. The scariest attacker most tech bros face, it's their own data, slowly rotting underneath them. We call this long-term, slow-motion poisoning model collapse. Think about it. Modern AIs are constantly refreshed on the latest from the open web, but that web is now stuffed with their own recycled, AI-written sludge. This feedback loop makes the model blander, more generic, and less connected to reality over time. But what truly raises the stakes is the intent behind data poisoning. It became a powerful tool of resistance and self-defense against surveillance and unjust prediction. The ultimate targets are the black box systems that assign risk scores with real-world power. I'm talking about predictive engines built by companies like Palantir. They take billions of seemingly innocent data points like social media connections, utility bills, public records, and create a likelihood score. A score for everything from credit eligibility to who gets granted parole. The most dangerous predictive algorithms are the ones that determine who to target, arrest, or deport. If an algorithm can pull intimate, legally sensitive truths out of grocery runs, like the example of a person who has suffered a miscarriage, then the stakes are literally life and death. So the defensive strategy is simple. Intentionally flood these systems with plausible noise. If enough members of a non-targeted group introduce false contradictory signals, like mimicking a profile they don't have but is targeted, they dissolve the model's confidence. The goal is to make the system confidently wrong when it matters most and waste time and resources. It's possible to take collective, defensive action to make the underlying data so untrustworthy that the people relying on the targeting system can no longer trust their most crucial risk scores. This is the real security story. Sometimes the attacker is an activist, using the system's dependency on clean data against it. If the whole environment is becoming one big, poisonable training set, what does that actually mean for regular humans and anyone who just wants to defend instead of just doom scroll? How you hack the matrix back. So if the whole world is one giant, poisonable training set, here's the part nobody at tech companies wants you to fully internalize. You can fight back. Right now, your social media feed is basically a weaponized nervous system hijacker, filled with rage bait, fear bait, disaster clips, and everything is on fire takes. And all of this stuff is a business model. The longer you're in fight or flight, the longer you're glued to the screen. And the longer you're glued, the richer they get. Data poisoning at your level is how you start breaking that spell. Here's how it works in practice. Create a new social media account and treat it like a doorway to a different timeline. On this account, you are not allowed to feed the rage machine. Instead, you scroll past outrage immediately. Refuse to click anything that spikes your anxiety or cortisol, and only engage with content that would actually make your life better in 6 months. That would be stuff like life skills, joy, health, how to be calm, real problem solving, and actual humanity. At first, the algorithm will keep shoving chaos in your face. It's testing you. But the algorithms are loyal to patterns. If you act bored by the panic and obsessed with things that actually nourish you, it will change your algorithm, and that will change your reality. The one made of recommendations, suggestions, and you might like this will start to feel a lot less like a trap and more like a tool you can use for your own self-development. That's you poisoning the model's version of you on purpose. Not everyone has to unplug entirely from the matrix to make this work. So you can actually stay inside of it and still take your power back by refusing to play the role that they wrote for you. If you like this video about data poisoning, then you will love this one about how to become invisible online in 2026. I'll see you in that one next.